Good morning students, welcome back again. This is grade 9, subject mathematics, chapter number 2, polynomials. Okay, today we talk about exercise 2.1. Let's see. Before that, we look some definition. First one is monomial. What is a monomial? An algebraic expression which is consists only single term is said to be a monomial. That means suppose this is consist only single term, that means one term. Okay, suppose 4x square, simply y minus 3z, these all are example of a monomial. Similar way, what is a binomial? An algebraic expression which consists two terms is said to be binomial. Suppose this is consists two terms. Example 2x square plus 1. Okay. Then y square minus 4. Or you can use another variable also, z cube plus z square also. These all are example of a binomial. Similar way, now next definition is trinomial. Trinomial, an algebraic expression which consists three terms is said to be a trinomial. Here look 3, that means 3. Okay, so this trinomial consists three terms. And what is the example? X square plus 2x plus 1. This is an algebraic expression which consists three terms. That means this is said to be trinomial. I take one more example in another variable form. 2y square plus 4y plus 1. This is second example of trinomial. Okay, monomial, binomial, trinomial. Similar way, polynomial. What is a polynomial? An algebraic expression which consists three or more terms is said to be polynomial. Okay, this is a basic concept of polynomial. So let's start. What is exercise 2.1? Question number first. Which of the following expressions are polynomials in one variable and which are not? State reasons your answer. Okay, so we have to identify which one is polynomials in one variable or not with reason. So what is first example? 4x square minus 3x plus 7. This is a polynomial. How we check given statement is polynomial or not? To observe a power. If power should be whole number, then it's a polynomial. So 2 is a whole number. As you know that in our previous chapter, w is the set of the whole number and 0, 1, 2, 3 up to infinite all are whole number. So this power of x is 1, these two are whole number. That means this is a polynomial. Got it? We have to check only power, no any other digit. Got it? Now second. Now here this is a constant term because it has no any variable. So this is the y square. So again this power in a whole number. So this is a polynomial. Okay? Now third one. Now this time this variable has a cap. If I simplify further one more step, so 3t raised to 1 half. What is a 1 half? This is the square root of t plus t under root 2. Here the power of t is whole number, but here the power of t is 1 half and 1 half is not a whole number. So this is not a polynomial. So third one is not a polynomial. With reason. What is the reason? Reason is here the power of the variable t are not included in a whole number. Got it? Similar, again I further one more step, y plus 2 into y raised to minus 1. If you convert this denominator in a numerator, it will be y raised to minus 1. That means ultimately this term has a negative power and whole number not including any negative number. That means this is not a polynomial. Okay? And last one, it obviously there are used three different variables x, y, z. So answer will be here. This is a polynomial in a three variable, not one variable. In this example, here x is only one variable. Okay, this polynomial in a only x. That means only one variable. Here also this is only one variable, use y. This is t. This is again y, and this is x, y, z. So this is polynomial, but not in one variable, three variable. So in this fifth number, you have to write down this is a polynomial with three variable. Okay. Now look, second question. Write the coefficient of x square in each of the following. Now, what is the meaning of coefficient? Coefficient, that means that number which is multiplied with variable. Okay. So here variable is x square. We have to write down the coefficient of x square. So you have to check which number is multiplied with x square. Only you have to check x square, not x, not any constant term. So this is x square. So which number is present to multiply from? So here nothing, but you can assume as a 1. 1 into x square, that means 1x square. So coefficient of this first example is 1. Okay. Now look, x square, so multiply with minus 1. So coefficient of this is minus 1. Similarly, x square, with x square there is a pi by 2. So coefficient of x square is pi by 2 in this example. Got it? You have to only check that number which is multiplied with x square. And at last, here in this polynomial there are no any term of x square. So how we check? Simply there are no any term with x square. So there are coefficient is 0, or you can write also plus 0x square. This is meaningless term. So coefficient of this polynomial is 0. Got it? Okay. Now look, question number 3. Give one example each of a binomial of degree 35, binomial of 35, and of a monomial of degree 100. So there are many type of example, infinite example. Just write whatever you think in your mind with power 35. So I write x raised to 35 plus 1. This is a binomial. Why this is a binomial? Because it has a two term. If any polynomial have a two term, it's said to be binomial. And what is a monomial? If it has only one term. So with power 100. So example of this is x raised to 100. Simply just write, or you can write y raised to 100, or you can write z raised to 100. You can use any variable. Not compulsory you have to use x variable. Got it? Okay. Now fourth one. Write the degree of each of the following polynomials. What is the degree of a polynomial? Degree of a polynomial, that means the highest power or the maximum power of a polynomial. So here look, this is 3 power. You have to check only power, not coefficient. Okay. So 3, 2 and this is 1. So highest power is 3. So degree of this polynomial is 3. Okay. Now here highest power is 2, so degree of this polynomial is 2. Here t raised to nothing, that means you have to assume there is a 1 present. So degree of this polynomial is 1. Here there are no any variable. So what happened? This is a constant term. What is a constant term? A term is said to be constant term if it has no any variable. So degree of constant term is always 0. So answer will be 0. Okay, I hope you all have understood. Okay, now look question number 5. Classify the following as a linear, quadratic and cubic polynomials. Okay, we have to check which one is linear, which one is quadratic, and which one is cubic. Okay, first of all, what is the definition of linear? If polynomial have a 1 degree, then it's a linear. If 2 degree, then it's a quadratic. If it has degree 2, and cubic if it has degree 3, and for linear it has degree 1. Okay, so what is the degree of this polynomial? 2. That means this is a quadratic form. Q for quadratic. Okay, here degree is 3. That means this is a cubic. This is a cubic polynomial. Second one is here degree is 2. So again it's a quadratic. So it's a quadratic polynomial. Got it? Now here degree is 1. So this is a linear form. So write this is a linear equation or linear polynomial. Again power of this t is 1. So again this is a linear. Power is 2 or degree is 2. That means it's a quadratic polynomial. And at last power is 3. That means it's a cubic form or cubic polynomial or cubic equation. Okay, this is all about exercise 2.1. I hope you all have understood. Even if you have any doubt, you can ask me in our live session. Till then, take care and thank you very much.